It's one part of the generative AI. How are we going to use the large language model in enterprise use case? Okay, so everybody would have gone through the chat GPT, and but few, not all the organization are open to open the chat GPT. Chat GPT is one of the application of the large language model, but we have different use cases for the enterprises we can adapt using a large language model. So we will start with little basics, then we can go dive into the large language model, because here people will come with a mixed experience. I just want to start with a little basic. And I just want to talk about our community. This is a Cloud and Loud tech community. We have a separate user group called Data, Gen AI, and ML Labs. Here we take a frequent session, and all the session we cover the topic in depth with a sample code and live use cases. People who are interested, you can follow along for the further events. And about me, I'm a INR J. Krishnan. I started my career as an hardware technician. With my continuous learning and my passion towards the technology, I have currently 18 years of experience, and I have a 50 plus certification. I worked as a lead engineer, as a DevOps, MLOps, ML and data platform in multiple roles. I have spoken at 20 different public events on ML, AI, Gen AI, MLOps, and DevOps. And currently I'm working as a VP and principal engineer at one of the financial organization. And again, guys, my passion, it's really towards continuous learning and sharing the knowledge. So your feedback and questions are most welcome. Okay? Thank you. That's about me. And I am a AWS community builder under the machine learning streams. AWS Community Builder is a AWS program which aggregated for the individual who love to share their knowledge on the AWS topics. If you want to be a AWS community builder, feel free to connect with me. I can give you some pointers. That's about me. Let's go to the session. What are we going to talk about today? We're going to talk about what is Gen AI and high level overview about the transformer. Then we touch upon the AWS Foundation model. Then we little bit pick up the gear and talk about leveraging the LLM. What is prompting? What is fine tuning? What is a lang chain? And before giving a use case, we understand what are the challenges in adapting in enterprise. Then how do you leverage AWS in enterprise to deliver the business value with a demo. And I'll have a couple of points where we will stop and we will discuss on it. Okay. So path towards the Gen AI. Okay. So everybody would have seen we're talking about Gen AI, but it came with the path is little bit different from the Gen AI, how it started. It's all started with previously we are talking about the descriptive analytics. People created charts, graphs, and if you have went through the UI, take an Excel sheet. People do a lot of analytics on Excel sheet with the raw data, and then the Power BI or the Looker. A lot of tools came up in AWS. You can use the quick sites. So it is more as a descriptive analytics. The data is there. You are building a value by showing the images and everything. Sorry, the charts and everything. Then comes the predictive analytics. People who work in the machine learning, they can easily understand in the basic terms that are linear regression, logistic regression, or clustering. Let's take a simple example of linear regression model. So the example is previously, let's say, taken as sales data. You have a 2020 data. You take the data and give the prediction about what happened on, give a chart about what the sales on that particular 2020. But in the linear regression, you can give a 2021, 2020, 2021, 2022, and that will help you to predict what will be the sales for the 2023. It's a simple example for the linear regression. Then comes the predictive AI. A lot of models came where we were two different streams get into the picture where in a AI, one is a NLP and another one is a computer vision. Okay, so it's all more as a descriptive or the predictive. Let's say descriptive in the sense you give a train the data with the labels. If you are giving 100 images of a cat and showing one of the image, it is giving you the prediction. Okay, same way with the word, you can give a sentimental analytics like the Google reviews. You take it and say good, bad. You need to label it. Then you can give a new novel data, it will predict. That is the stage. There comes the next one, generative AI. Now we are talking about the transformer model. At the same time, this NLP and computer vision is booming, there is a one more technology, GAN, came into the picture, where it will generate the. It work like a police and the simple thing is it's work like a police and mm, a thief. Okay, so there will be a discriminator, and so we will give a input data. The new one will challenge the data, so it will create a novel data. There comes a transformer model. We are going to talk about the transformer model now. That's where the lot of evolution happen. We will talk a little bit deep on the transformer model. You take all most of the models like a Falcon, or from the Mosaic MPT, or the Dolly from the Databricks, or GPT, Bloom, Flanty 5. But all those models are based out of the transformer technology. Okay, and this is for the NLP side. At the same time, there is a stable diffusion on the imaging side. Okay, we're not going to talk about the stable diffusion on today's call. We plan to have a separate discussion about the image generative. Okay, but we are mostly focusing on the NLP side, which is a transformer model, as a large language model. Okay. Okay, this transformer model was done on the 2017 NIPS, which is a conference, a worldwide conference for the natural language processing. So in that conference, the Google presented the transformer architecture. The original idea for the transformer is not for the generative AI. The real objective for the paper is to do the translation. The classic example is we are all know we have a local, we are all regional language. So if you translate to the language to the English, the words will be different. The position of the words will be different, correct? So that's the same challenges was faced while you are doing with the French to English or English to French or the German to English. So what they try to address is they build this transformer model for that particular use case, and they pointed out three important things. One is uh, context, which will before, and the data will be given as an input, and inside the data will be giving in as an input. Here you will have a multi-headed attention where it will understand the context. I'm not going to deep dive into the uh, transformer paper. The simple, I just want to have better understanding at the high level is, so it will, the data will be here, and that multi-headed attention will try to understand the relationship between the words you have given. Then it will be given as a sequence, but to the next layer it will be given as a parallel. Okay, so it will give understand the context before doing the translation. Okay, and they have two layers. One is encoder, which will be take the input sequence in the vector. uh, Anybody want to know what is vector? So if anybody want to know, just message. I can quickly walk through because that's very important.
Yes, Ayana. Yeah, I want to know.
Okay, good. I will give you some high level overview because this will set a good context on what you guys want to. So here, what I'm trying to do is I have a four corpus. I love playing back football. Football is my favorite sport. This is a four corpus I'm having, and like us, we take a data as a visual format. In a model will take it as numerical representation in a vector format only. So here what we are trying to do is we are converting this word into the vector. This is a vector representation of the football. Okay, this is the corpus. I'm trying to find out what is the vector representation of the word called football. Then I try to understand the similar words to football. So since a lot of there are a lot of corpus trained on this one, it says love is similar, then playing is similar, worldwide is similar, and the vocabulary size. This is the vocabulary size of the whole corpus. So it is giving you the vector representative here representation. Okay? Here this will give you the correlation, cosines relation information. Let us do
Ayana,
the same.
sorry to
Sorry,
interrupt. Are you doing something? We are
sorry.
seeing transformers.
Oh, okay, okay. Oh, sorry. I was showing my different screen. Okay. Thank you guys. Okay. So if we go here, this is sample notebook. So we have a corpus. I love football, and football is my favorite sport. These are the four corpus. What am I trying to do is I'm completely converting this into the vector and giving a vector. 1 minute. This is a vector representation. This is the football vector representation, and it is giving what is a similar word to the football. Since we have only that certain corpus, it says the next word is love. The next next similar word is playing. This is giving a similarity. Okay, this is trying to convert the word into vector. Now, what I'm showing you in a 3D. Okay, see, football is my favorite sport. I love playing football, and basketball is exciting game. So you see, if you're seeing the distance between the football is my favorite sport and the basketball is an exciting game, this is distance is more. So, but here the distance is less. This is the relation. This is how at the high level it works. Okay, if you take the real-time example of any e-commerce website, I say I want a Nike shoe uh, on LeBron James 2015. So you are giving the whole word, okay? So it will go and check the description where it has a content word, and it will show you the recommendation. It cannot take only one word and one word and give you the prediction. So the embedding will convert the word into the vector and search what is the similarity and give you the output. Okay, this is very important. Uh, this is the first stage it will do. It convert the input sequence into the vector representation on the input layer. Here in the multi-headed attention, it will understand the whole correlation of the each word, and it will be given send as in a parallel to the decoder one. Okay, here it will give you the thought max. What is the probability of the next word prediction. It's all at the end, even if you're using a chat GPT or any AWS Jurassic AI model, it all go token by token prediction only. And each word, the next word will be find the probability and give you them. Since it's happening at very fast, you will not notice it, but it will be showing in a token by token. That is what the transformer model was doing. And why does it altogether change the game is because of the previously we are using RNN, LSTM, and GRU. The model, the biggest challenge is it will lose the context. Okay, I'm just giving you a recap before going there. It lose the context because the neural network is not scalable enough, and if you want to retrain the any new model, you need to again retrain the whole corpus and retrain the model. And it's all going in a sequence. The lot of innovation happen at the GPU or take example of a Trainium from the AWS, but it cannot leverage because still the input has to go in a sequence. But transformer from one layer to another layer, it go in a parallel. Okay, so that amplify the adaption of transformer model for NLP, or I say large language model. Let me come to the large language model. Why we call it as a large language model is we are training with a huge corpus of the data, and we call it as a pre-trained model. It can be multiple parameter. Let's say if you're taking a chat GPT, if everybody is going, the GPT model is 175 billion, and the BERT model, which we are talking about before, this that is 40 billion, if I'm not mistaken. And l- uh, these are parameter, but a lot of it's not about the token. It's not a corpus of the token. The corpus of the token will be more. So what is the challenges in adapting the enterprise is pre-training the model from the scratch. Okay. Anybody in the currently who are in the call, anybody from your telling that my company is telling that my company is doing a model from the scratch. I want to put up the numbers. Okay, if you want, you can check it on the Google. To train the model, they have spent 400 million. Okay, dollar one triple sale of training the model, the GPT model, cost at 400 million. Okay, you can go because it's so expensive and it run for a month and it need a high power compute to do it. Okay, so the adoption of the enterprise, small and medium enterprise or the big enterprises, creating the model from the scratch. And the second one is data privacy, security, and ethics. And if you are using the pre-trained model, the problem is the data privacy and security and the ethics. The third one is model interpretability. Okay, so you cannot, you don't know, it's a black box. You know what is happening inside the model and why this prediction is coming. Okay, so this is another, that is not much responsible AI or the evaluation metrics available for the large language model. And fine tuning and customization is also a big challenge. Okay, still it need a lot of compute. If you really want to customize and live within your data, within your network, that is a big challenge. Then very important is continuous model improvement and integration. It demand lot of tool. Okay, if you want to have a continuous integration, or is it connected with your data properly in a secured manner, and do we have a proper pipeline? Do we have LLM ops properly set up for doing the continuous integration, evaluation metrics? So these are all the big challenges in adapting into the enterprise. Uh, this as per my understanding. If you feel like you have more, feel free to pass it on. Okay. Right. And take a couple of questions. Guys, before I'm jumping, do you have any questions? I saw one question from Prasanna Kumar. I just need to know about transformer. I'm still confused on that. Yeah, okay. The best way to know the transformer is there is an you message me on LinkedIn. I can pass it to you. Okay. There's a wonderful video which go for 1.5 hours. And they will explain in a detail. Okay. These are the foundation model available in SageMaker Jumpstart. If somebody don't know what is SageMaker Jumpstart, I'll walk you through during the demo session. Okay? So Jumpstart is nothing but they already published a pre-trained model where you can easily consume. Okay. Very important thing while you're adapting the model, you need to understand what is open model, what is a proprietary model. Okay, and whether it is encoder model or decoder model. And who are all in the call, can anybody answer whether you may be definitely logged into the ChatGPT? Is it an encoder based model or decoder based model? Fantastic, Simrat. Yeah, fantastic, guys. Okay, it's a decoder based model. Okay, any idea what is the advantages of a decoder and encoder? Just high level. Okay, uh, decoder will be working very well on the large corpus and faster token to token generation, and but it will, yes, exactly. Okay, decoder for the generation, the token generation, and encoder for summarizing the data. Okay, correct, man. Thanks, Kiran, for joining it. Okay. Um, so then, what is the open, and whether the Chat GPTs or the GPT models are open or closed? And a lot of models are the llama and dolly. Okay, and why do we need to worry about the whether open model, it need to be open model or it need to be closed model? Okay, the important thing is, if you really want to use a large language model to train based on your use case for the fine tuning, it need to be open. If it is a closed, you cannot do it. There are some mod inside the open model also. There are two divisions where whether it can be used for commercial or it cannot be used for the commercial, which you need to always take into the consideration. But whatever the model which is provided by AWS, like a stability AI for the task like or the Alexa TM, or foundation model done by the Hugging Face like a Flantify or Falcon, which is a very good model. Okay, these are all publicly available, but there are proprietary model like Cohere, Lighton, and AI 21 Labs. The one good thing about the proprietary model is they have done some fine tuning on the RLHF and then some kind of sanitization of the data, which we'll talk about at the end of the session why it is needed. Okay, but if you are using public data, you have to be very cautious and understand what kind of data set they use for training. Okay, before going there, any questions on this information? What is public? What is proprietary inside the public? What is open? What is closed? Okay, thank you. I'll go to the next one. I'm touching upon what is the prompting. Okay, now since everybody would have gone through touching upon the chat GPT, you would have know what is prompting. Okay, it is about uh, you you can choose a choice of the LLM. In the chat GPT is powered by the GPT model, but you can use anything from the Hugging Face or the AWS Foundation model like a Jurassic a model which provided by AI21 Labs or Stability.ai, where you can give a text as an input, English text as an input for now, but there are a lot of other models are coming up where you can do for the other languages. Okay. Let's take an example, write a blog about India cinema. Okay. And if you want more particular about India cinema between 1950 to 1953, the better you give the context in the window, which is a context window where you give your input, the quality of the model will be it. And using the large language model, you can create a text. You can summarize the text. You can give it two paragraph and ask them to summarize in a single paragraph, or you can do the translation, say English to French, French to English, and as well as code. You can give a sample command, and it will give you the code and question answer. Okay, there are multiple way of doing the prompting. I'm not getting into that particular topic where you can do the zero shot prompting or you can do the few shot prompting, chain of thoughts. Okay, I'm not getting into that topic, but this is a high level understanding about the prompting. Then comes the fine tuning. Okay, so the disadvantage of the prompting is limited to the context window. You cannot give 500 pages of the data into the context and say predict. No, it cannot do it. There is a limited amount of the uh, information you can do to give it in the context window. Then there comes the fine tuning. Okay, so here you have a data set where you already have a pre-trained model. Let's take one open source model like a Falcon TB, um, a Bfloat 16. You can take that model, or you can take a sorry, I put a GPT. Okay, you can use the GPT-J, but you cannot use the other one. Okay, so you can take the BERT. BERT is a classical example. Okay, you can give your own data. Let's say if you are from the medical professional or if you are from the insurance professional, you can give your own data and you can use the pre-trained model and fine tune the model with your data. But all the parameters, let's say if you're taking a Falcon 40 billion, 40B, it's a 40 billion parameter that which you need to completely retrain using all the 40 billion parameter, which will take a lot of compute. Okay, but it's still doable. If any company want to only live within their data and live within their context of the data, they can do the fine tuning of that but pre-trained model of their choice. But it is, as I said, the major concepts, computer cost, the compute cost and time to train. It will, based on your data, based on the parameter, it will take time to train the model. Then there is a parameter efficient fine tuning option came. Here, what will happen? It will take the pre-trained LLM and it will keep the original weight and bias. The parameter, I say the parameter is frozen, and they will add an adapter. I say they will add another layer of that model. Then they will train with your data. Okay, here you can it with a fraction of the cost. I say 1/10 of the cost. You can fine tune the model. Okay, there are multiple technique you can use. One is a low rank adaptation of LLM, or you can use a quantized. Quantized is nothing but most of the time we'll be using a 32-bit for uh, as an input. Here, what we do is we'll quantize to the 16-bit, which will help you to the precision will be reduced. Very simple as if you take a pi, uh, if you it will take 3.1493752. The precision, what does it do is it reduce 3.145 bit. The bit will be reduced. Okay, and the another one is sparse quantized representation, but it is not much used. But this is giving there is a loss when you are doing the quantization. There is a loss of the precision, but if you are using a sparse quantize, that loss also will be reduced. That is the advantage. These are the three techniques you can use while you are doing the fine tuning with the PERFT. This is very important based on the end, because enterprise, they want to make sure they are fine tune the model in a cost effective manner, so they will adapt to PERFT to do the fine tuning their model. Then this is very, very important. People who are a developer of Python or JavaScript, I highly recommend you guys to take a look at it. You no need to know the nitty-gritty of the language model. You can understand basic prompting, and you can use the lang chain and build a fantastic application. Okay, low rank adaption. Okay, see, I'll go. I'll take this question at the last. Okay, Samit, I understand what you're asking. Can you explain low rank adaption again? I'll go through that again. So LangChain, the very important thing for the LangChain is they have multiple components. One is the model, the LLMs and the prompts. So you can select the choice of your model. You can use the same. It's a Python. It's not a language model. It is a framework. It's nothing but somebody is write a very good uh, mm, wrapper around the prompt engineering and giving you which can we can build a fantastic application. And they add a lot of plugins, and a lot of advancement is happening in the LangChain now. So using the same LangChain, you can use any kind of model. You can use the GPT Turbo, or you can use your choice of your model with the API key. Of course, you have to use the API key in your Python program in a secure manner. Then chains, you can use multiple models based on your use cases, and you can interact with the external data source. You can connect with your database also. You can connect with your vector database like Elasticsearch, or you can use the Pinecone, or you can use the vector database. Okay, um, use that, and where you have your own data, which will connect your data and build an application on top of it. And then there is a memory is very important, because if you're building a chat application, okay, I'll take the question last, guys. Okay, because more demo need to be done. Okay, so the agents, right? So no, memory is very important, because if you are creating a chat application, you need to understand the context of what you have given before to give a prediction next. Okay, so the memory is part of the lang chain, which will keep the how much time you need to keep the memory and optimize for your output. Okay, so anybody who are interested in LangChain, please check the documentation. That is going to be, I think, very useful if you are building an application on top of a large language model. Then comes the RAG. Okay, so we have seen what is a prompt. Then we have seen how to fine tune. Then we have seen what is the best way to do the fine tune. Then we are talking about what is a RAG. Okay, so it's a retrieval augmented generation. The simple thing is it will take the data and chunk the data, because in your context window only certain amount of the tokens can sit. It chunk the data, convert into the vector, as we seen before, convert into the vector and store into the database. Okay, um, so if you have seen the Elasticsearch, it by de facto it will comes with some kind of semantic search. Okay, if you take AWS Open Search, it comes with a default semantic search. Okay, um, here we are keeping the vector information into the Elasticsearch. Now this data is your own proprietary data. Now you are giving an input as a prompt, and what does the prompt will do? And what you are instructing is get the data from your own knowledge source, where it will go check in your database, vector database, and take that context along with your prompt, and it will send it to your large language model for prediction. Okay, let's say if you're asking who won the IPL 2023, do you think you will get an output from the ChatGPT? Anybody can say yes or no. Who won the NBA? Okay, yeah, because there is a knowledge cutoff because it trained until 2021 September or 2022 September. I forgot. Okay, so but the advantage of RAG is you example. I don't say I'm not asking you to crawl the quick info information put into the database. I'm saying you can crawl the information and add it to this in a frequent manner, and it will give you the prediction. Okay, if anybody want to know what is the prediction, what is current score, or who won the match between the Ashes between the England and Australia, the recent Ashes, and if you are using a ChatGPT, it is not going to give information. You can use a RAG, but if you're not updated, crawl the data and update it to the RAG, it will not give the information. So that's where you can use a RAG. The okay. So I want to understand what is a RAG. Now you understood the RAG. Let's all glue together here. You understand prompting. You have a fine-tuned the model based on your use case. Now you have a RAG. Yes. Now you can build the application using a LangChain. LangChain can connect to the vector database. It can live within that context of okay. Here, yes, LangChain can connect to your vector database. Not only vector database, it has a connected to your database also. You can connect your database and get the prediction. Okay. You can use the agents to you can say who let's say you have a database, have a marketing data, finance data. Okay, you can use a LangChain, build a chat application on top of it, and you can ask the question. Okay, can you find how many sales happened on the last month? It can, the LangChain will take that as a prompt and connect to your database, and it will understand your question, and it will use that agent and convert that to the SQL interpreter and run that execution on your database and give you the output. That can be done via LangChain. Yes, you can do it. Okay. We talked about all those techniques. Now, let's understand what is the advantages of using AWS. Okay, the flexibility. Okay, so it gives you the building your own DL container from the scratch. You can use a PyTorch or TensorFlow. You can use your deep learning container. Now they have a lot of foundation model container also going to be it's available. Okay, and secure the customer. If your data within your database, let's say you are living in Aurora, and if it is running and you no need to bring your third-party SaaS application like a Pineco. You can use your Elasticsearch as a vector database. That's advantage. And again, most of the time you keep your raw data into the S3, which is very much useful. And you can use a VPC endpoint to make sure the data connection is secure and cost-effective infrastructure. You can use a Trainium, the stability AI, which is build image models. Okay, they were using AWS Trainium Ultra Cluster to train their model. Okay, so it is highly efficient. Then they have an inference here, which is meant for the inference. Both done at the ground up level. It is done by the AWS Annapurna Lab, which is it's an Australian firm acquired by the AWS, and both the computer meant for the particular purpose Trainium, because Trainium it need a large compute, it need a better network for the better scalability. So it will be available in multiple region. In Francia, it will be available in certain region, but it need to give you the faster throughput. Okay, for the as an endpoint. And they also given if you anybody want to need to be a vendor agnostics, if you want to use a Graviton or NVIDIA GPU, you can use it. Okay, and even you can use a Habana Gaudi from the Intel. And once you build a model, that is not the end of story. Okay, you need to have a better integration with the existing capability. Okay, particularly large language model operation, which we are planning to take a session in upcoming meetups. Okay, it's really important. It's completely it's little bit different from MLOps, but it's needed. Okay, and as I mentioned, integration with a vector database like Elasticsearch, that is also very much important. Then generative AI powered solution. The Bedrock API is not yet released, but once the Bedrock API is released, you can use the same way how you are using API from the Open API platform. The same way you can use the Bedrock API. Under that, you have variety of the foundation models available, which we have seen before. Okay. Okay. This is a simple use case I have taken. We have only I finish up this use case discussion, then I will take a question, then I'll go for a demo. Okay, guys. So sample use cases, you build an application. There is a flow. This is a real, you have a Confluence database in your enterprise if you have a Confluence database, and you are already documenting all the best practices, the Java best practices, the code pipeline best practices, and DevOps best practices. You keep on adding, okay? If somebody is joining newly to your company, okay, and they started working on the project, what if you feel like they can have a chat window, they can type the question and it take the data from the Confluence rather than they are going link by link to the Confluence. Good, right? It's fantastic. So that is what we can achieve. I'm just giving a sample use case. I'm not saying this is a use case you have to use it. This is one of the use case which you can. I just want to address. Okay? So the moment first flow I want to read through, you get all your corpus data and write the data. There is an embedding model. Okay, there is an embedding model. You read the data and write it to the Elasticsearch. Okay, and you create your SageMaker pipeline, which automatically read that data and use the SageMaker embedding, which convert the word to vec and write it to the Elasticsearch, which is a vector database. Now you have your data. So example, you can take it from the Confluence and dump it on S3. Then you can use a SageMaker processing pipeline, which will use a SageMaker embedding model. We are using a GPT-J in a demo and writing to the vector database. Now, the moment give a user given input, the input is from the Streamlit. It's a Python web application. The the API gateway will take the input and use a Lambda function and give us a prompt to the that LLM model, which is going to give a text generation. Along with that, this Lambda is going to get the contacts, additional contacts from this vector database and going to pass it to the SageMaker endpoint. So you have your prompt, okay? Who won the who won the IPL 2023? And it will go check in a vector database. It has updated information, and it will go give it to the SageMaker endpoint, and we'll give you the story. Okay? So there's a two endpoints here. Okay, one is for the embedding, one is for the endpoint. Okay, this is one use case, and you can apply the same use case for multiple things. Okay, and okay, this is just a flow. The SageMaker processing will checkpoint the data crawl based from the and keep it in S3, and we crawl the data and write it to the open search with the embedding. Tell me what is SageMaker. Okay, sorry guys. Okay, so SageMaker is an AWS machine learning platform where you can. It's like anybody working as a different cloud provider. It is like Azure ML Service or Google Vertex API. It's an end-to-end platform. You can build, train, and deploy your model in a scalable and easy manner. Okay, so okay, I will, before going to the demo, I just want to tell, stay tuned for the future session. We have future session coming, how to save your ML cost 40% using a SageMaker, Trainium, Inferentia, and in your SDK. And we planned for a code whisperer, which is like a code pilot if you guys are using it. Build a serverless application with a prompt. Okay. And fine tune the enterprise data using a LoRa, QLoRa on AWS SageMaker. However, okay, let me go through the question, and meanwhile, I'm checking whether my demo is ready or not. Okay, guys. Okay. Okay. What is the question? SageMaker open source model don't really work well with the rack. They just give the prompt and context back with the solution. See, it's all about the parameter and the corpus of the data they tuned, right? Okay. Um, we have to use a bigger model. If what model you guys, Kiran, what model you used? Kiran asked the question. Open source model don't really work well. If you're using a Flantify, it won't work. If you're Falcon 7B, can you try Falcon 40B, which is newly released? Yes, yeah, you can use that one. Yeah, B float 16. That model you can use. The people are recommend. I not tried by myself, but I saw a lot of blogs. They're telling it's working very well. Okay, that's open source model. Okay, then are there working example for fine tuning on data, not an instruction data set? Ex- Not an instruction data set, question and answering. Okay. See the fine tuning, Vijay, there is a question. You are asking about the fine tuning of data, right? So fine tuning is set multiple things. What you are fine tuning? What technique you are using a fine tuning? Vijay, you are there? Okay. So based on your technique you are using, it will vary. Okay. If you are using a full fine tuning, or are you going to, or are you using a PEFT with a LoRa? Based on that, it will change. Approximate cost of LoRa. LoRa is not a planning to use LoRa. Okay. Um, See, you can use a SageMaker to train your model in a single click, but based on your model, I can tell whether it is available in SageMaker or not. Okay, that's one thing. And any working example, yeah, we plan to have a session. If you want to have a detailed session, stay tuned. We have a session. Okay, Arvind, you have a question? Yeah, go on, Arvind.
Yeah, so you are talking about open versus closed model. As I
Yes,
understand, open means that you can fine tune the model. Is my understanding correct?
yes.
Okay, I just wanted to check that. Yeah.
Okay, okay. See, there are few you can fine tune, but not all the models you can use it for. Commercial. That is one more thing we need to keep it in a consideration. Okay.
Okay, got it.
Okay.
Yeah.
Because it's very important. If you are using a Llama model, it is open. Okay. There's a history behind it. It's open, but you cannot use it for commercial. There is a return. But if you read this recent innovation happening, and Databricks is an AWS partner, you can say that Dolly is one model which is open source. You can use it. Okay.
So as a follow-up, in one of your slides, you mentioned uh, like GPT as a possible base model for fine tuning. So does that include the latest release of
No,
GPT or
no,
an
no,
older
no,
release of
no.
GPT?
Best of my knowledge, no. It's a closed only. Okay, I may be wrong, but it's closed.
You
People
mean you
can
cannot
comment.
fine tune GPT?
You cannot. There are no open. GPT is not from the open AI, which is everybody using nowadays, right? GPT-4, which is the multimodal, or GPT 3.5, which powering the Chat GPT. That is not open. Okay, that is closed. It's by the open AI, but it is closed. But
Okay.
there is a model called GPT-J, which is we are going to use it for the embedding. That is open. Okay. So there are a few more sites I can help you guys. Okay. One is Helm. Okay. Helm LLM. Okay. This is I'll putting in this slide here. See here, it will give you about the each model. Okay, what are the model and whether it is open or not, access, whether it is closed or not. All those information you can see it. It's a C Bloom, which is open. Okay, and Jumbo is limited. That then you need to understand what is the licensing about it, whether you can use it for the testing on the research purpose, but you cannot use it for the commercial purpose. Based on that, it will keep changing. Okay. This is the model. This is one I'll put it on the chat link, guys. You can use it. Okay. Okay. So any question I missed, guys? Okay.
One more question, just yeah.
Go on. Go on.
See, you talked about interpretability. Yeah, obviously for these kind of models, it is difficult.
Yes.
But one of the things I found interesting is when I use Bing search engine.
Yes.
So there now they have a chat option.
Yes.
So it's better in terms of, I don't know whether you can call that interpretability, but for suppose an answer has three lines, for each line or potentially for that bunch of lines, it will give the source from where it got the data. Now, I have not seen ChatGPT do anything like that, but that link to the source, that is very useful because it brings certain credibility to the answer.
That you can do with a RAG. Okay, at the end, but the backside they are using a RAG where they connect to the data source. You see a lot of plugins are happening, right? At the end, they are all using a RAG to connect to it. Okay. So I try to run this demo. 1 minute. Any other question, guys? Meanwhile, I'm checking. So even if you're using a RAG-based model, if you're using like a SageMaker, or keeping a open search as in your, this is a demo I want to give. Okay. What does it do is it will, the endpoint is powered by the text generation is powered by the flan T5, and the embedding is powered by the chat GPT-J. Okay, and this will convert the text which it is crawling the the site, the some document site, and writing to the Elasticsearch. And while I'm asking a question, it will give me the answer. Okay, so this is a use case we are seeing, right? Okay, so where am I? Here it is. This is a use case I'm going, right? The moment I give you the web application, it will connect to the API gateway and take the prompt from the Lambda, and the Lambda will take the data from the not take data. It will take the additional context from the Elasticsearch and go for endpoint. That is what I'm trying to demo. So the model is running. I'll go through the console. There's people who don't know what a SageMaker, that will be useful. Okay, I'm here. I'm going this. I try to give a demo example also, but if not, in interest of time, I'll walk you through the process a little bit. Okay, so it will be useful to people who have not done it. Okay? So this is a SageMaker. So you have a foundation model. We were talking about the foundation model before, right? You have a lot of foundation model. The 40B instruct. I just not given the Falcon. Okay, so you can try this, and then here we have a three things. One is endpoint, which I want to show you. Friends, SageMaker endpoints. We have two endpoints. One is endpoint for the embedding. Another one is the endpoint for prediction. And there is a pipeline processing job, which it will read the data source and write it to the write it to the Elasticsearch. Okay, so I will give you the example code. Okay, it's stuck in some stage. Okay, so I'll give you this code. This is a vector. Some demo before that. Okay, so here, what is this is a code. It will read the data from the source and write it to here. Okay. So it uses a LangChain. Here, I'll walk through the code. We are installing the libraries, the LangChain, and we are connecting to the data source, which is a website. This is the website we are connecting to. And we are in chunking the model. The chunk size is 600 because it is a small model. the text generation model is small model. The context will be very small. For because of that, we are chunking the model. We read the data, and we will writing the data. We are reading this from the cloud formation endpoint, and writing. We are using an embedding model and writing this to the S3 bucket. Then from the S3 bucket, we are uh, we are crawling the data and loading to the Elasticsearch. Okay, so first step is we reading to the Elastic from the website and crawling the data and writing the XML file. See, these are the XML file it crawled, and now we are loading this to the Elasticsearch. We are converting the text and to the vector and the writing to the Elasticsearch. And we are using here, we are using a files index, which is on the local mode, but you can use the Elasticsearch also. And this is a step which we are writing to the Elasticsearch. Okay, the advantage of the Elasticsearch is it's a distributed, it will scale. Okay, and this you can see it will give you the count. Okay, so it is writing, it is reading the data, it is loading the container for the GPTJ and creating the endpoint, and this is the processing job which will run all the tasks we were given above. Okay, here it is writing the data to the Elasticsearch. Okay, and here after that it do the some testing by do the similarities testing. I think it is I'm getting some error. Oh yeah, no, it shows. Okay, it is saying how to create a custom XG boost container. It will uh, read the it will use the endpoint, and from it was giving you the output here. Okay, so you can see the output. Okay, so this data we are crawl the data from the website and wrote to the Elasticsearch using a GPTJ model as a embedding model. And now we are reading the data by giving the context. This is the context. This is the input they have given how to create the container, and we are getting output from the SageMaker endpoint. Okay, text generated SageMaker endpoint. We have some two endpoints, right? This is text generation endpoint. So if you look at the demo, what we want to do, this is what it's exactly doing it. Okay, the UI is not working. The UI is nothing but it will help you give a prompt from the UI, but in the notebook you can see it. Okay, I think we are at the chat. SageMaker Jumpstart support GPT-2. No, I don't think so, guys. Okay, you're asking prompt engineer local GPT is good. I not tried it. I can try and let you know, guys. So, any questions before we are finalizing the session? Thanks. Before that, thanks one each and everyone for staying tuned at the late evening and connected for the session. Really helpful. I request everybody to give your feedback. Okay, as I and this is my LinkedIn. If anybody want to join LinkedIn, and if you are looking for recording, share me, connect with me on LinkedIn. Based on that, I'll share it information. Okay. And if you have any interesting use cases, feel free to connect with me. I'm happy to share best of my knowledge. And ready to take a couple of good words. If you have anything, people can speak.
Yeah, hi, Ayanar, Arvind here.
Thanks, Arvind.
Yeah. So I joined 5 minutes late by the time you guys have started.
Sorry,
So
I want to
just some
respect the other's
closing
time, so I joined the time.
remarks from me.
Yeah, thanks, Arvind.
Yeah,
Go
so
on.
thanks for giving that very useful overview of transformers, ChatGPT, and the whole process of the data pipeline. And then along with that, your insight or expertise in AWS is, I think, also going to be a very valuable, knowledge for those in this call. So thanks for that. So hope to see many more sessions from you on this.
And we are planning for a generative AI workshop. It's more as a take one. Now I just walk through the code. I can, since interest of the time, I just glanced it. I can go a little bit deep onto it. We are planning very soon where we can have a one-on-one session plus this session plus additional context how to build application in a layered format. So we are planning. Stay tuned. If anybody interested, connect with me. I can see what is my time availability and your requirement and align to it.
I have a question. It's regarding that LoRa training course, right? Is it depends on the corpus size or actually? You said actually for the GPT it costs 400 million for training. So is it in proportion to that level?
No, no, it's not a person to that. Okay. So when come to the model, right, you need to understand the parameter. Okay. Its parameter is not only weight and bias. Okay. So every parameter will take a additional memory footprint. Okay. So that's why the more parameter comes, I'm not going nitty-gritty, the more parameter goes and the memory will keep increasing. Okay. But we are all talking about in a 32-bit precision. The low rank, what does it do? It will reduce the precision little bit. Okay. So and it add an additional layer on top of it on the existing white and bias, and it reduce the precision on training the parameter. Okay. You are not, the simple thing is if you are having a 40 billion parameter, you are not retraining 40 billion parameter. You will be retraining say 1 by turn 1 by 10th of the parameter, which reduce the 1 by 10th of the cost. There are not all the parameters are tunable. In that, you are taking what is the important parameter to be tuned and do the predict and have a your model. While you are predicting the model, you will give your foundation model also. You give your trained model also to do the prediction. Okay.
Is it like transfer learning in the context of CNN?
Exactly. You take it as a transfer learning. Okay. Fine tuning is nothing but a transfer learning. You have a pre-trained model. You are adding your data and doing the fine tuning. But the fine tuning, if you are fine tuning the 40 billion parameter model, it is going to have a lot of compute. Okay. You need to tune all the parameters. Okay. Don't think like the large language model is a data set. Okay. Database or something. It's a reasoning engine. It just to predict the next token in a better manner. The more corpus data you use, the more parameters, high parameters with a good, better corpus data you use, the better prediction of the next token. Very simple. Okay. But if you want to, rather than completely fine tune those model, we are only tuning certain parameters with the LoRa or QLoRa or SQPF. Okay. So only we are only using training only particular parameters. If you're taking 30 billion parameters, you may end up in training 3 million parameters, which is 1 by 100th of the this one. That's the advantage where you are, yes, if you predict, if you give an evaluation of your prediction about your full fine tuning and the uh, perfect fine tuning using a LoRa, you will see little precision will be low, but that is a trade-off you are doing rather than doing the full training.
So that for the trained new 3 million parameters, right? The weights and biases would be different, and rest of the things would be the old one.
Yes, yes.
Is
You
it?
can use the transformer library from the Hugging Face. They have everything. You can. That is the next the workshop we are planning, right? You are using a Hugging Face library doing the LoRa. If you can do it via UI also, it's very intuitive. That is also part of the next workshop. You can use the AWS console and you can do it in a UI, the fine tune model in a very easy manner.
Okay, thank you.
Okay, I only know about the Q LoRa and LoRa. I not touched the GGML. Kiran, I can check it and get back to you guys. We are more into the Azure Databricks as an organization, very used to position on varied. Oh yeah. we, we will that's see the AWS part I touch is only 10 to 15% part. The rest I have completed touched upon the technique, which is very important. Okay. Yeah, we can in future let's see whether we can talk about the different cloud providers and the Databricks. We are planning from Databricks solution architect is planning to come and give a session from our group. Very soon we will organize one. Thanks, guys. In the we are about 4 minutes. Thanks. We started on time. We finished on time. I request everybody to share your feedback on LinkedIn. Okay. And if anybody want a session one information, connect with me on LinkedIn. I'm happy to share the same thing. Okay.
Can we share this shared session, recorded session?
Yeah, you connect me on LinkedIn and I'll send you